Okay, like I was saying in the previous video, the hole in the base plate here is the minor diameter of the threads. The screw is a major diameter, so that's why it appears that way. Okay, let's go back to shaded. All right, now this other screw over here, I'll use regular constraints, not the insert for it, just to kind of show you how that could work. And what we'll do is we'll go axis of the cylinder hole, axis of the screw, okay, and that inserts it, okay. And now we want to do a mate, okay, with the top surface of the counter bore and the bottom surface there. Okay. All right. So now our screws are free to rotate, and as far as a model goes, that's okay. But when it comes to doing our drawings, we want those screws to be lined up. Anytime we have screws, nuts, bolts, fasteners, things like that, we want to constrain them so that they don't rotate. Because once we create our drawing, if they rotate and change in the assembly, then that messes our drawing up. And we have certain ways that we like to look at drawing fasteners when they're in a drawing. So with this one, let me look back and see what I had here. Okay, I had them perpendicular there. So what we'll do is we'll do an angular constraint, and you can, if you've got surfaces, you can use surfaces. If you've got if not, then you can use the axis of a part, and I'll show you both ways. So we'll go angle, and we're going to go directed angle, and I'm going to choose this surface and one of the vertical surfaces of the slot, and I'm going to say 90 degrees, and I'm going to say okay. All right, and so that locked that screw down in place. It won't turn. The other method, using axes, I'll expand the origin here so we can see that. So that is the YZ plane. And I'll expand this one. So that's my XY plane. So now what I'll do is I'm going to constrain these planes together. And I want that one. That one's the perpendicular one, the XY. So I'm going to go there to there at 0 degrees. Okay. And see that worked too. So either one of those ways will work for you. It's no, either way is good. It's good to know both ways to do that. And this thing's pretty good. This top part is free to rotate, but because it is symmetrical, there's nothing that, that could change on it. Really, that's, it's okay. You can put an angular constraint on it to lock it down. Either way, that would be good. Okay, so there's your assembly, totally constrained. Let me check my notes, see if I got anything else to say. I think we're good with that. So use a pack and go to submit this according to the instructions in Blackboard.